Hi, today our group will be discussing the gas laws, relations between various properties of gases, mainly ideal gases. Scientists take into consideration these few assumptions, also known as the kinetic molecular theory, that define an ideal gas. The first assumption is that all the gas molecules are in constant random motion. Their pathways cannot be predicted nor predetermined by external factors. The second assumption states that the collisions between gas molecules are completely elastic, meaning that the total kinetic energy is conserved and the momentum of the molecules stay constant. The third assumption states that there are no attractive forces exerted by the particles on each other nor the surroundings. The particles move independent of one another and its environment. The theory also describes that the particle sizes are infinitely small, so that the individual particle volumes are negligible in the context of calculations. The final assumption states that the kinetic energy is directly proportional to the temperature of the gas. The more movement of the particles, the hotter the gas. At absolute zero, particle motion comes to a complete stop. After establishing the basic assumptions of the kinetic molecular theory, we can move on to discussing the gas laws, relationships between the pressure, temperature, volume, and quantity of the gas. The first gas law is Boyle's law, stating that pressure and volume of a gas are inversely proportional. As you decrease the volume, the pressure increases and vice versa, as seen as the graph. This law is seen when trying to pop a balloon. Squeezing the balloon reduces the volume, increasing the pressure inside. Due to this high pressure, the balloon bursts. Charles' law states that the temperature and volume of a gas are directly proportional. As the volume of the gas increases, the temperature increases as well, as seen by the graph. For example, a helium balloon on a cold day will crumple, as a lower temperature will correlate to a smaller volume. However, moving to a warmer room will inflate it to its normal capacity. Gay-Lussac's law states that the temperature and pressure of a gas are directly proportional. As the pressure of a gas increases, the temperature will increase as well, as seen at the graph. An example of this can be seen when an aerosol can is heated. Due to the high temperature, a proportionally higher pressure will cause it to explode. The ideal gas law combines the previous equations as well as a molar relation to derive the equation PV is equal to nRT, where P is the pressure in atmospheres, V is the volume in liters, N is the number of moles, R is equal to 0.0821 liters atm per mole Kelvin, and T is equal to temperature in Kelvin. Different variations of the ideal gas law can arise through manipulation of the molar mass, number of moles, and volume, leading to an equation involving density. Pm is equal to dRT, where m is the molar mass in grams per mole and density d